Welcome back. So, in this section of the course, which is, by the way, optional, we are going to talk about Big O. Now, Big O is one of these things that you just have to know if you want to be good at writing any kind of algorithm. Reason I'm saying this section is optional is that some people watching may already know about this. If you're one of these people, please feel free to jump right ahead into the interview questions. Now, before we go any further, a small warning. This section will contain some math. Now, if you're not really keen on mathematics, don't worry about it. First off, it's not crazy math. And second, I'll make sure to try to explain it as simply as possible. And you should know that the rest of the course wouldn't be as mathematical as this one. Of course, there will be some math in the later sections, where I'll also explain it then, but this section will have a tad more math than the rest of these sections. Now, let's start off with the goals that we would hope to achieve by the end of the section. First off, I'm hoping that you would be able to describe Big O notation. You'll be able to simplify Big O expressions. You'll be able to define time complexity as well as space complexity. And of course, you'll be able to find out the time and space complexity of different algorithms. Finally, and that's the math part of the course mainly, you'll be able to describe logarithms. Now, before we go any further, we'll have to understand why do we actually need to understand this stuff? Why do we study Big O notation? And let's see an example. Say we have two implementations for the same problem. You have two codes that do solve the same problem, both of them. Well, how do you know which one is better? Which one do you go with? Big O will give us some sort of framework of defining which code is better. But the question here is, why is it important? Well, when you're dealing with petabytes of data, efficiency does matter. So what I was saying earlier of like which code is better, you may have thought, well, why does it matter? Well, it may not matter if, say, you're dealing with a couple of arrays where each array is of size 10, but imagine you're dealing with hundreds and hundreds of petabytes of data. In that case, efficiency does matter, and this is where Big O comes in. Now, Big O gives you a way to express the efficiency of your code, and it helps you to make trade-offs between space and time, whether your code would take in more space, for example, or will it be quicker, faster. And the less important part, and perhaps for you that's the most important one, is that Big O notation is very, very much asked in interview questions. You can be sure that in every interview question that you'll make, basically, you will be asked to write some code, solve some problem, and in the end, you will be asked to analyze your code from both the space perspective and the time perspective. So let's get started.